Excuse me, sir.
हेलो।
यस सर। सर एक डाउट था, पूछ सकते हैं क्या सर?
हाँ हाँ बोलो।
सर ये जैसे कि जो माइक्रो प्रोसेसर पेपर है, तो सर आप कभी मतलब अगर टाइम मिले तो हम लोग को क्वेश्चन करा देंगे क्या, कि मतलब किस टाइप का क्वेश्चंस आता है?
हाँ हम असाइनमेंट दे देंगे।
ओके
इस
सर।
टाइप का जो क्वेश्चन है ना।
हाँ सर, क्योंकि सर एक्चुअली ना प्रैक्टिस हो जाता, पता चल जाता कि किस टाइप का आता है, तो उसी हिसाब से हम
हम
लोग
अभी
प्रिपेयर कर।
अभी अपलोड कर देते हैं हम क्लासरूम में।
ओके सर।
और जो ज्वाइन कर रहे हो ज्वाइन करने तो 1 मिनट वेट करो, ज्वाइन करने के तो सबको ठीक है, उसके बाद स्टार्ट कर रहे हैं हम क्लास। क्वेश्चन कुछ अपडेट दे रहे हैं, ठीक है। ये कुछ सैंपल पुराना दूसरे जगह का था, इसको अभी अपलोड कर देंगे। तो प्राची हम कुछ क्वेश्चन दे दिए, ठीक है। अपलोड हुआ क्या? नहीं तो हम इसको स्टडी मटेरियल में दे रहे हैं।
एक्सक्यूज मी सर।
हाँ बोलो।
सर इसको कैसे सबमिट करेंगे, मतलब पीडीएफ बना बना के ना?
नहीं 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 नहीं, इसको अपना जो नॉर्मल कॉपी में लिखते हो ना,
हाँ सर।
क्वेश्चन तुमको शो कर रहा है ना।
हाँ अभी हम खोले सर, उसमें मतलब एमसीक्यू भी है और मतलब
हम
सब्जेक्टिव
सब
भी है।
कुछ डब्ल्यूबीटी लिखे, डब्ल्यूबीटी का क्वेश्चन है, कुछ सैंपल पेपर। तो इसको क्या करना है, जितना
हाँ
पॉसिबल है उसको क्या करना है, अपना जो जिस कॉपी में आप लोग नोट बनाते हैं ना, उसी कॉपी
हाँ
में
सर।
लिख के एट द एंड आपको जमा देना। देखो इसलिए हम 15-20 दिन का टाइम दिए, उस हिसाब से आपको
ओके
जमा
सर।
देना। क्योंकि इसी
ओके।
टाइप का क्वेश्चन आपका आएगा, एमसीक्यू भी आएगा 10 मार्क का। उसके बाद जो ये है, अभी कुछ कुछ क्वेश्चन शायद कुछ प्रॉब्लम हो सकता है, ठीक है। हाँ, तो उसको वो उस क्वेश्चन को छोड़ देना, और नहीं तो मेरे से बात करके उसको लिखना है,
हाँ
ठीक है।
सर, जितना आएगा उतना बना लेंगे, बाकी फिर आप बता दीजिएगा।
मेरे मेरे हिसाब से लगभग 95% कवर अप हो जाएगा, ठीक है। अभी तक जितना हुआ है उसमें
ओके सर,
95% का कवर अप हो जाएगा।
थैंक यू सर।
ठीक है, और तो कोई नहीं ज्वाइन कर रहा है, हम स्टार्ट कर रहे हैं। छोड़ो। वॉइस क्लियर है ना सबके पास?
यस सर।
ओके। अच्छा, सम ऑफ एन सीरीज नंबर ये हुआ था, ये तो नहीं हुआ था। सम ऑफ एन सीरीज नंबर,
सर एक बार पीपीटी दिखा दीजिए सर, मतलब अगर हुआ होगा तो याद आ जाएगा।
अभी शो कर रहे हैं ना जो और फाइल जो खुले हमने?
यस सर।
तो ये है सम ऑफ सीरीज नंबर, मतलब जैसे जस्ट फॉर 1 2 5 6 7 8 कोई भी नंबर, मतलब 10 और 10 to 20 नंबर पर 10 1 to 100 नंबर ऑफ सीरीज नंबर को हमको सम करना है। तो उसके लिए क्या करना है, वो हम लोग सेम मान के चलो, जो मेरा जो वैल्यू है वो इनिशियली एलेक्सा रजिस्टर पेयर से मेमोरी को पॉइंट आउट करेगा, मेमोरी से उस वैल्यू के लेना है मेरे को, और उसके बाद हमको ऐड ऐड करते करते जाना है। क्योंकि अगर 10 नंबर होगा तो टोटल नंबर ऑफ एडिशन 10 और 9 होगा। दो दो टाइप का एक होता है, एक में 10 होता है, एक में 9 होता है। क्योंकि 9 का भी रीजन है, क्योंकि अगर एक्यूमुलेटर का हम लोग 0 करेंगे तब टोटल नंबर ऑफ टाइप ऑफ एडिशन के इतना होगा। अगर 10 नंबर होगा, 10 नंबर को 10 सीरीज ऑफ नंबर को ऐड करना है तो 10 होगा। अगर एक्यूमुलेटर में कोई प्रीवियसली एक वैल्यू ले लेते हैं आउट ऑफ 10 नंबर में, तब एडिशन होगा नंबर ऑफ 9, क्योंकि तब काउंटर वैल्यू हो जाएगा मेरे को 9। और इनिशियली द काउंटर वैल्यू इज, जितना नंबर लेंगे, अगर 5 नंबर ऑफ सेट नंबर लेंगे होगा, अगर 10 लेंगे तो 10 होगा। So the program is write an assembly language program of sum of series 8-bit number। तो 8-bit नंबर को हमको सम करना है। तो फर्स्ट ऑफ ऑल to load start as same load HL register pair with address of counter memory location। काउंटर मेमोरी लोकेशन को ये करना है, और नहीं तो हम लोग डायरेक्ट मूव द काउंटर वैल्यू, और if the value is 05 then it can be copied into counter register which is defined, or in our case is C register, जो MBI इंस्ट्रक्शन यूज करके भी कर सकते हैं। लेकिन यहाँ पर हम लोग जो किए हैं LXI इंस्ट्रक्शन यूज करके किए हैं, जो लोड HL रजिस्टर पेयर विथ एड्रेस ऑफ काउंटर मेमोरी लोकेशन। देन नेक्स्ट क्या किए है, जो काउंटर का जो वैल्यू है वो हमको C रजिस्टर में मूव करना है। देन मूव द काउंटर फ्रॉम रजिस्टर मेमोरी टू रजिस्टर C। देन क्योंकि हमको रिपीटेशन ऑफ एडिशन करना है, तो हम लोग प्रीवियसली जो कोई भी वैल्यू है, प्रीवियसली जो वैल्यू लोडेड है, उसको एक्यूमुलेटर के वैल्यू को हम लोग क्या करेंगे, हम लोग उसको इनिशियलाइज बाय 0 करेंगे, बट क्लियर करेंगे। मतलब सपोज प्रीवियस ऑपरेशन द एक्यूमुलेटर कंटेंट इज 86, but in this program we can clear the accumulator by using MBI a comma 0 a comma 00। So by initializing the accumulator with 00 hex, then we can increment the HL register pair to point the next memory location। Because why? Because this data, which data is to be fetched, is to be loaded in any register, So increment HL register pair to point the next memory location. Okay. Now move the next number from memory to register B. Memory to register B. After that, we can using add instruction. We add the value of B with A. We can add the data of B register with the A register. So initialize the value of A register is 00 and B value is which we are assume. Okay. Then after that we can addition. After addition, the value of the first addition is the value is loaded or the result is loaded into A register. After that, what happened? We using DCRC instruction decrement the counter C register, because previously counter value is is it trained, then it can be decremented because on operation already performed. If the counter value is 0, then if yes, then increment the HL register pair to store the result or addition result in particular memory location. If no, then it back to again this step, back to again HL, increment the HL register pair to point the next memory location. Okay. So first you see the value. So here is a before execution we loaded the memory location value is 300 hex contains 05 because number of series data is 5. So we can design the counter by value of 05. After these are the value 3001 hex is the value is 02, 3002 hex is the value is 04, 3003 is 03, and 3004 is 02, and 3005 is 01. Okay. So now see the program, and after the execution the addition result is 0C. So now the program to initialize the load LXI register pair to with the address of 3000 hex, because 3000 hex memory location is contains the value of counter. So after this point the counter value, the HL using LXI H 3000 hex load the HL register pair with address 3000 hex, and lower order value of 3000x here is 00 and higher order value is 30. After that the memory content is copied into C register, which in our program which is as a act as a counter. So the copy the value of memory location or memory content into C register. So number of series data is 5. So memory content is 05 value, and that value is copied into C register or move into C register. And after that we are use MBI instruction, which is MBI comma 00 hex to initialize the accumulator with 00. Or then after that the I next H means increment the register pair HL to point the next memory location from which data is to be operated or addition is to be performed. Then after that incremented we use the move instruction B comma M, which is 46. Move next number from memory to register B. Memory to register B. After that on data is moved from memory to register, and another data already loaded in accumulator which is 00. Then we add two data using add B instruction. We using add B instruction. So here use the add instruction. Use the add instruction which is add B. Add B 80. Add B with A. Add B with A, and after that addition, first addition counter is declared by using DCRC. Counter value is 0, then go to the next step, means INX H. If counter value is not 0, then go back to this memory location, means that 2006 hex memory location, means this, back to this memory location. If the counter value is not 0 or C register value is not 0, then back to memory location 2006. Okay, and after that if the value is yes, then increment the HL register pair to the point the memory location. After that the move accumulator में value है after the addition purpose, addition करने के बाद, so move the accumulator value into memory for storing purpose, and our program is completed. So is there any doubt in this program? Hello, hello, that is the explanation. Is there any doubt?
No, sir.
Okay. So another program is write a assembly language program to sort the array in descending order. Two program is on, one in descending and order, another is ascending order. One is descending, another is ascending order. The first one is the descending order, means that this is our, this left hand side is the our input, which is 05, 15, 01, 65, 32, and write an assembly language program to sort the array in descending order. So descending order is 65, 32, 15, 05 and 0. So right hand side is the output of this program, and this is the input. This is the input. Okay. So input is 0, 5 and 0. So in this program we assign a to counter. To counter means previous program is only we assigned the only on counter, but in this program, because here is the, it can compare the which number is greater than and less than, and also is can be arrange the descending, arrange with a descending order of a series of number. सीरीज ऑफ नंबर, अगर सिर्फ एक नंबर होता तब तो ये नहीं होता. So we can, in this program we can initialize a two counter, counter 1 and counter 2. So first block is that start block, and then next one is the initialize the counter 1, next is the counter 2, and also HL register pair, initialize the counter 2 and also HL register pair. After that the next block is the move the number from memory to accumulator. Move the number from memory to accumulator. After that first number is moved from memory to accumulator, then it's increment the HL register pair to point the next number of memory location, to point the next number of memory location. Then after that, क्योंकि हमको डिसेंडिंग ऑर्डर में सजाना है तो उसके लिए क्या करना है, कंपेयर करना है. तो यूजिंग CMP इंस्ट्रक्शन वी कंपेयर द नंबर इन मेमोरी विद द नंबर इन accumulator, number in memory with the number in accumulator. So is there first condition is that if is there A is greater than M, agar if it is yes, then it back to increment stage, and if no, then it interchange the number, agar no hoga, then it can be change its position, or means that it interchange the number, means A content will interchange with the M content. Okay, means the value of M is load into A and A value is load into M. And if the value is yes, then it can be increment next and increment the HL register pair to point the next memory location. Again the decrement the counter 2, decrement the counter 2. Agar counter, if the counter 2 is 0, if the counter 2 is 0, then back to this step. Agar no hoga, then it back to load, move the number from memory to accumulator. अगर no होगा then back to the अगर yes होगा तो A क्या होगा, decrement the counter 1, and again the check the whether the counter 1 is 0 or not. If yes, then stop the program. Agar if no, then it can be point out the this block, means the initialize the counter 2 and load HL register pair, means load the HL register pair. अगर no होगा तो इसका explanation देखेंगे first. तो इसका explanation में क्या है देखो, just 1 second. To first sort an array in descending order, let us assume that there is a 5 number in array. In the array is total number is array, the data is 5 number of data, and which is the starting address is 3000 hex. This is the 3000 hex. So the starting address is 3000 hex, and now we can initialize the counter 1 and counter 2 are initialized with the size of an array. This is the size of an array, and after that HL pair is point out to the starting address of an array. So first we assume that the number of data is 5 in this array and starting address is 3000 hex, and initialize the counter 1 and counter 2 are initialized with the size of an array, means that array का जो size होगा उसी के हिसाब से आपको counter 1 and counter 2 को initialize करना होगा. अगर 10 होता तो counter value will be 10, अगर 20 होता तो counter value will be 20. So if the counter value depends on the size of an array, and after that the HL pair is pointed to starting address of the array. HL pair is pointed to the starting address of the array. Okay, and so HL pair क्या कर रहे हैं, point out कर रहे हैं, तो हमारा जो array है उसको point out कर रहे हैं. तो in this first iteration, the first number is compared with the second number. The first number in first iteration, the first number is compared with the second number. If the first number is greater than second number, then do not interchange them. वो जो ब्लॉक ऐसे ना, अगर ये होता तब इंटरचेंज होता वैल्यू, अगर नो होता दिस कैन बी बैक इनटू द अगेन increment HL register pair. If the first number is greater than second number, then there will be not interchange them. And otherwise, if the first number is less than second number, then swap them, means interchange them. Swap them means interchange them. And after that, the next iteration, the first number is compared with the third number, because the first number is greater than second number. So first number already previously loaded into our accumulated, and accumulated value will be compared with the registered value. So next data value is the third number value is compared with the first number. If the first number is greater than third number, then do not interchange them. Otherwise, if the first number is less than third number, then swap them or interchange them. And in next iteration is first number is compared with the fourth number, and the process continue until the counter 2 becomes 0. In this process will be continue until the counter 2 value becomes 0. And when the counter 2 becomes 0, counter 1 is decremented, and the process continue until all the number are arranged in descending order. So the iteration process will be continue until the counter 2 becomes 0. जब तक counter 0 नहीं, counter 2 0 नहीं होगा, तो ये जो मेरा comparison ये operation चल रहा है, ये continue चलेगा until the counter 2 value will be 0. And at the same case, when the counter 2 becomes 0, the counter 2 is decremented, and the process continue until all the number are arranged in descending order. Means after the when the counter 2 becomes a 0, the counter 1 is decremented, and the process continue until all the number are arranged in descending order. So all the number is arranged in descending order. Now see the program. So firstly, I says that our array size is 5. So we can load it 2 register, means both are count is the counter register. Both are counter register. One is counter B and another is one is B register, another is C register. So low initial is the counter 1 with MBI B comma 05, which initialize the counter, and MBI C comma 05, which the initial is the counter 2. After the initializing the two counter 1 and counter 2, we point out the address where data is to be fetched, or where the data is to be operated in this program. So LXIH 3000 hex, LXIH 3000 hex. So after the load HL register pair with the address, the using move instruction, move A comma M, means the move the number from memory to register A. Again increment the INX register pair to load the memory content with another or next data value from array. Then after that, CMPM compare the content of accumulator with the content of M content, or the memory content. Okay, compare the number of with the next number. So after the compare, it check JNC. JNC means jump if no carry. अगर carry generate नहीं करेगा, so don't if no carry, अगर carry generate नहीं करेगा, so then it can be jump into this memory location, means 2015 hex memory location, 2015 hex memory location. Do not interchange if the number is A, क्योंकि carry कब generate नहीं करेगा, जब the value, when the value of A or accumulator is greater than memory or register content, then there will be no carry is generated, means that carry flag is reset, also the zero flag is reset. So next condition is that JZ, though JZ agar jump if 0 means JZ, next condition is jump if 0. If the number is equal, JZ means when the zero flag is set, means when the jump in 0. Agar zero flag is set hoga, means the both value of the memory, in this case the memory content and accumulator content got same hoga, then the zero flag is set. So do not need the interchange operation if the number is equal to the next number. Okay, so now next is that if the number is greater than memory content, so swap is needed, means move d comma m, move d comma m. Okay, so otherwise swap the number or move the next number from memory to the register, and after that again we using move instruction, because the accumulator content is move the first number from accumulator to memory, and then decrement the register pair, decrement the HL register pair. Okay, after the decrementing, the move the D register content into memory location. Then again we increment the HL register pair to point the next data, and after incrementing we decrement the counter 2. After increment the HL register pair, we decrement the C register or counter 2 register. If the counter 2 is 0, then go to next step. Agar if this will be not 0, then back to the 2007 memory location, means back to this memory location, and again this repeat the all the operation to performing to finding the descending order of data. So it check J and J jump if no not 0. If the counter is not 0, then it will repeat into this memory location, means 2006-7 memory location. And after that the decrement the counter 1 by using DCRC, decrement the counter 1. Then if the J engine jump 0, agar 1 is 0 nahi hota, then it can be back to the again repeat step, means this can be 2002, means this step. Okay, and after the this step it can be, क्योंकि जब ये 0 होगा तभी मेरा पूरा जो डिसेंडिंग ऑर्डर में हमको सजाना है वो कंप्लीटेड हो गया है, और नहीं तो ये फिर से बैक, दिस कैन बी बैक इनटू द 2002 location, which is the counter 2 location, and then our program is completed, which is using halt or stop the program or execution. So this is the program for descending. This is the sort an array as an descending order. So descending order में हमको अगर ये करना है तो उसको हमको जो करना है वो है 2 काउंटर लेना है, और जितना काउंटर ऐसे करके डिजाइन करना है जो एरे के, इट्स कैन बी डिपेंड्स ऑन द साइज ऑफ एन एरे के साइज के ऊपर डिपेंड करेगा. सो इन दिस प्रोग्राम 2 काउंटर विल बी डिजाइंड एंड द काउंटर वैल्यू and the value which to be compared or to arranged in descending order, which is on value is loaded into accumulator and another value is loaded in memory location. After that, it will be compared with the accumulator value is compared with the memory location, or if the memory location content is less than accumulator, then there will be no interchange is required. If the memory content is value is greater than accumulator value, then it can be interchange or swap. So we can swap by using the DCXC instruction, decrement the register pair, and after that we using the move instruction, move move m comma g comma m to swap the number or to move the next number from memory to another register, which is d register, which is d registered. So a array का size कितना होगा वो डिपेंड करेगा, and using these two instruction, this one is j and z, another is j and c and j z, because there are two condition is applied. On is j and c means jump if no carry. Agar jump if no carry, then the first number is greater than the next number, and if the number is equal, so it's check the using z instruction, which is jump if 0, means that in this case the value of memory and accumulator both are same. So if the number is equal to the next number, so this condition will be satisfied, and if the number is greater than is the next number, then this condition is satisfied, means that the first number is greater than next number. And otherwise three condition. First condition is first number is greater than second number. Second condition is first number is equal to second number, means there will be a zero flag is set. And third condition is the value of accumulator or the first register is less than second register. If the value of first register or the first number is less than second number, then there will be a swap in needed or interchange is needed. Otherwise there will be no needed of swap in this program. So this is the program for descending order of an array, descending arrangement of an series of number or array of number. तो ये तो गया मेरा डिसेंडिंग. अगर असेंडिंग होगा तो यही सेम प्रोग्राम रहेगा, जस्ट इन सी जस्ट a highlighted portion means in this just this instruction only change this instruction. In j and c it will be used jc, jump if carry. अगर ascending order में हमको सजाना है तो only on instruction is changes, which is using jc. So I think that already all the program of 8085 related program is completed. Only one or two program is left, which is stepper motor interfacing or stepper motor and 7-segment display. So all the program, because addition, subtraction, multiplication, where lookup table, byte shifting, marking the cornable, rotation, largest, smallest, and word event and ascending or descending, all are completed. So for ascending you can only change the value of jc, jump if carry. Jump if carry means the first number is greater than or the second number is greater than first number. Second number is greater than first number means that memory or register content value is greater than value of accumulated. So only the changes is needed. Only JC is replaced in by JC is replaced by JNC. JNC की जगह मेरा JC होगा. Just यही चेंज होगा, बाकी all are same. So जो क्वेश्चन दिए हैं हम, ठीक है,
यस सर।